This presentation will look at the key principle within the .NET framework, which is .NET remoting. Much of .NET is actually built on this remoting infrastructure. So the first key principle that we have is the definition of remote objects. And remote objects are typically seen within distributed systems. In this case, rather than building applications around local DLLs, local objects, what we can do is we can distribute these objects around a network to make it more robust in general, so we can easily update components on a server. We can make sure there are multiple versions of a component, so that if one server cannot provide it, then another one can. We can also subscribe in the cloud computing, where we can actually access objects remotely in the cloud. So some systems that we've seen in the past include the RPC protocol, which is remote procedure calls. This is typically used in a Unix type environment. For this, we can mount file systems and directories, printer servers and so on, and then we issue them with RPC calls, of which there is some reply that comes back. We've also seen it in Microsoft networks with the DCOM model and with Corba, and the method that Java typically uses is RMI to remotely invoke remote objects. One problem with these types of technologies is that they are typically seen as insecure and are often banned from access from external networks into an internal network. So the model that we have is that we can have objects, and we'll just call them objects from now on, remote objects distributed around our systems, and then our application or assembly can then access local objects or can access remote objects. The key principles that we have within this is the concept of a communication channel, and then also of a formatter. It is the formatter which is able to send an object or a reference to an object over a network. Obviously, over the network we can only send one bit at a time, so we need to make sure that we serialize any objects that we have and then build them back up in the same way. As we'll find, the two main formats are in a binary format and in an XML encoded format, typically using SOAP. So we can have local objects, and we've probably seen how we use these. We create class files and then we create new instances of our objects. For our remote object, we need to make sure that we understand the format of our remote object. So we have the concept of a communication channel over which we communicate, and then we can have different types of formatting depending on whether we need to be highly compatible using SOAP, or whether we need to be fairly fast and not necessarily compatible with a binary format. So our basic system might be to have a remote object that we create. So we create our class, and the class might be in a different assembly. We create a new instance of that class to create our remote object. Now what we must do is that we must invoke it remotely, because it might not be running. It's typically a DLL, and the DLL is then invoked or run in some way. We then pass an object or value to it, get some result back. A key factor is that we are typically using different assemblies between the local application and the remote object. So a key factor for us is, does the object stay alive once we get our result? So in some applications we might want the object to stay alive, and for this we could go back and continually access it, or in other cases, once we've got the result, then the garbage collector will come along and actually remove the object. The .NET framework actually has some advanced features when we look at COM+, where objects don't actually have to be deleted. They can be put into a pool and then reused again. So inside our local assembly, we typically use things like this, where we pass an object by value, or we pass by reference. Passing by reference allows us to be able to modify any of the objects that we have. Inside our remote object system, we must have some way to take an object and then we serialize it in some way, then encapsulate it within some formatter or encoder. In this case, we're formatting through SOAP. We communicate it over the channel, and then on the other side we do the reverse. We would decapsulate and deserialize, and hopefully we get our object back again. A key concept inside the .NET framework is the difference between client and server activated objects. So we get the concept of CAO or SAO, client activated or server activated. And the difference really is that in client activated objects, the client itself has control over the lifetime of the object. So with this, we typically define a lease time, and then once the lease time is up, then it will be automatically deleted by the garbage collector. For server activated objects, we can have two different types. A single call is where our local assembly calls the remote object, invokes it, makes the request, and then when the request is finished, then the object is automatically deleted. So these are used in applications where we just have a single call and then we do not need it to maintain its state. Singletons are stateful though and can accept multiple calls, so we can keep going back and making a call to the object, and it will have some remnants or memory inside it. In this way they can communicate with multiple clients or with the same client. The main namespaces that we require to make .NET remoting work are system.net, runtime.remoting, which we must add in as an extra .NET DLL, and web.services for our SOAP encapsulation. So the basic model that we have is this. We have our client object, and the client doesn't actually communicate directly with the remote object. It sets up what's called a proxy. So the remote client communicates with the proxy and not with the remote object. It is then up to the proxy to be able to correctly access the remote object. So we have then a remoting system, and the remoting system has some sort of serialization in it, and then it sets up a channel between the other side to be able to access the remote object. When we access objects locally, we can call them by reference or value. When we access them remotely, they must be marshalled in some way. And it's not possible to set up a reference because the reference doesn't exist in the local memory. So we need some way to marshal our remote objects. So the first thing we do on the server is to create our little DLL, and our DLL will contain the object. In this case, when we create the marshal by ref object, it creates a reference object and will automatically create a DLL for us. So in this case, we have a remote class called showCapital, which has a method called show. So what we're going to do is we're going to call from the client this method remotely passing the country, and we should get some idea of what the capital city is coming back. The key thing here is that we're creating a DLL, and then we can create this. We can put this DLL on our server machines. So in this case, our client can then access our remotable object. So we'd call it some given name, and then we can access the object and any methods with inside it if they are exposed publicly. So we need some sort of activation, and then we need some channel. In .NET remoting, we define a channel number, and this sets up a TCP channel. In this case, the TCP port is defined as 1234. So we need to make sure that the firewall will allow through this channel for the client and the server to be able to communicate between firewalls. So we have the concept of a channel. So the channels can either be HTTP, and HTTP, as we'll find, gives us high compatibility with firewalls, and that most firewalls will allow HTTP through, or we can have TCP. TCP communications are normally faster than HTTP. So in this case, we're setting up TCP channel of 1234, and we define that we're using a TCP channel such as this, and then we register that channel. So this allows us to make sure that the actual TCP port isn't being used by any other application. So the next key principle that we have is the actual activation of the DLL. So the DLL will sit dormant, and we need some method on the server to be able to activate and create the instance of the object. So we've seen that we can set up a channel, and that we set up our TCP ports. So we need to avoid standard ports such as 21 for FTP, 23 for Telnet, Web, and so on. So we might use TCP ports over 1024 because these are typically not used for standard applications. So we now need some way to activate this DLL. And as we've seen, the two types of activation are server and client activation. The client controls the lifetime of an object, where with server application we either use a singleton or a single call. The single call is used when the object is activated, we get our results, and then it is deleted. With a singleton, we maintain the state between function calls. So an example of a server activated object with a single call is where we might ask for a capital of a country, and it gives us back the answer. It doesn't matter the state, doesn't need to remember the last call, and so on. For a singleton, we might have a remote object which takes a login name, and we get a response of OK. Then we say send an email to Bert, and so on. In this way, we're remembering the state between our calls. And for client activated, we might have a remote object which is getting data, and we can keep requesting data from it. So after a while, we can actually delete the object once the lifetime has been reached. So the next thing we must do is to register the remote object. So the client needs to have some understanding of the interface to the remote object, so that the build is able to check all the accesses to the remote object to make sure that these are correct. So in this case, we have a remote assembly called show capital 1, and then inside that we have an assembly. We have a class name of new class, and then we have a method called showCapital. So the main things that we need to define are obviously the object mode. In this case it's a single call, and then a unique URI inside there to be able to identify the object, and we need to define what the name of the remote assembly is, and then we need to see what the actual data type is for our accesses. So we just convert our object back into a data type. So the method that we do this with is with the remoting config and to register a well-known service. So in this we define the data type, the assembly, and also we define the object and what the server activation method. Okay, so we'll create our object in a little minute. One other method that we can actually use is to define all these details, such as the port, inside an XML file. So rather than building it into the program, we can add it into a config file. This allows us, the users, to change the port settings and the activation methods externally to the program. So inside the client, what we do is that we register our new channel, and then we register this channel. In this case the channel is 1234, and then again we activate the object, and what we need is the type definition of the remote object, the assembly name, and so on. So these are defined on the client. So this allows us, if we add it as a reference to our project, we can take the DLL from the server and then add it in to our local project. Another method that we can use to actually find out what the details of the DLL are is soapsuds, and we can also create an interface class. Okay, so let's look at an actual example of creating an remotable class. So the first thing we do is to create our DLL. So on the server, and we'll just test it on the same machine, but it would easily scale to a remote server. So in this case we create our DLL, and it's a simple namespace, new class, and then we have a class called showCapital, of which there's a show method. We pass the country in and we get back the result. Okay, so let's now create our remote class. We just try and find our Visual Studio. Yeah, we have it there somewhere. So in this case we'll just do start. We'll just create a new project, and we're using 2008 here. So the first thing we do is to find a class library. So what we'll do is we'll create a new folder. We'll call it this, and we'll define new class. Just takes a little minute to open up, and then you should find there's an associated document that we get, and it goes along with this. And so the first thing that we do is to paste in some code related to the actual. Just give me a second, and here we have it here. So we can actually paste our code in directly in here, and if we want, we can actually define that as show capital. Okay, so we have our Marshall by reference object, and we should be able to build that, and that's worked perfectly. So we just have a little look just to see that it's created our DLL. So in this case, the DLL is contained inside here, and we just try and find it. So it's advanced security 2008. Okay, so here we have it here, and inside here, inside bin debug, we should have created a DLL. So this is our remoting DLL. It is this DLL which will be called up and activated. Okay, so we've created that. Next thing is to then add in our class, as we've done there. We've added in our code, so the key thing is we Marshall by reference object. From here, what we're going to do is to actually create the little program which will actually invoke the class file. So for this, we'll create a console application. It is the console application which will actually start up the DLL. So we'll just quit this, close project, and we now do a new project. In this case, we'll open up a console application, and we'll just call it new class 2. Right, and now what we must do is that we must add in the reference to a DLL so that it exposes the DLL. So we add reference. It just takes a little minute, and it'll be a standard .NET component. So we go back up to our class, it's here, and it's in there, bin debug DLL. The good thing is that it will keep a local copy of this DLL. So we now have that class within it, and what we also do is to add in the .NET remoting component. So we find the system runtime.remoting. Okay, so those are the two main references that we add. The next thing that we do is to add in our code. Here's our code here. And we paste that in. So we can see here that we're using channel 1234, and this is the name of our assembly, and we can see there's the method there's the object that we're actually calling, and it's a single call. So once it does one call, then it should quit. So we just build that, and then what we can do is we can execute it, and obviously it's trying to open up port 1234, so we'll unblock that. And our console application should run. Here we go. So it says just starting. So basically, it's waiting for us to develop the actual client application. So this is the service or the console application which will run on the server. So this is able to access the DLL. So we can keep that running, and then what we can do is that we could open up another Visual Studio program and we'll write the client program. So if we go back to our main presentation, okay, so this is what we've done. We've added in the DLL, added in runtime.remoting, and this is the code that is able to call the DLL. So both this program and the DLL run on the server. Now what we must do is we'll create a little Windows program, and it's the Windows program which we pass a country. We call up the remote method and it will return back a result which will display. The main thing is that we need to register the channel. Okay, so we now do that. So we'll go back to Visual Studio. So let's go and create this application. So we start off with a basic Windows form, and what we do is we'll add in some buttons. We'll add in a button and 2 text boxes. So we'll just get in our text box. So we need a button, and we need a couple of text boxes that we should find here. So this is where we're going to enter the name of the country, and it will return back in here the country. So we'll very quickly paste some code in. So let's take this code here and paste that in. And we've got some more that we need to add. So we add that up there. Now what we do is we need the runtime remoting component, and we also need to add in our DLL. So I've already done this. I navigate to the DLL, add it in as a reference. We can delete that and add it in again. And I've also added the runtime component. So I just add the reference by browsing and then finding our DLL. So in this case I found it here, and then that's added. So the client can now see the interface to new class, and then we can use it as a method. So let's try and build that. We've probably got a few errors. Copied in too many brackets. Okay, so that looks fine. So we just check to see if our server is running, and it hasn't. It's stopped. We'll just make sure it's running. So we do start. Just takes a little minute. Obviously this would be a standalone application that we would have. This takes a little minute to start up. Here it is. So it's started, and now we can go to our other application. And we can run this. So now what should happen is that we should be able to feed in a country. It will then call up the server, activate the component, and get the result back. Okay, so this hasn't worked, so we'll just check. So we have a slight problem. So now what we need to do is to now debug the application. So we just make sure that this is still running. And we just check. So we have 1, 2, 3, 4. And now we run the Windows application. Let's check where it's getting the country from. So the country comes from text box. We should be able to call it up, and then it should show our result. So we'll just give that a try. Right, I know what our problem is that we've not defined the event on the button. So we just go back here. All we have to do is go here and then select the button click. Okay, so now it should run. Okay. So we can put in the country. And we can see here what's happened is it's called up the remote component and returned back Edinburgh. We can put in another country that's not known, and it will give a not known for the capital. Okay, so let's just actually gather together all the little bits of programs that we've actually created. So here's the folder that we have. So with inside the new class, we actually have our DLL. Okay, so there is our DLL. So what we should find is we also have new class 2. With inside new class 2, then we created the server activation method. So with inside bin debug, what we should find is that we have an exe program here. So here is a new class, and notice that the DLL is also placed beside it. So if we wanted, we'll just make a directory called remoting, and we'll make a directory within remoting called server. So we'll copy star.dll into f.remoting server, and we'll copy our exe into there too. Okay, so now what we can do is that if we want, we now have a Windows application in here somewhere. Debug, and so we can see here that we have our Windows application. So what we'll do is that we'll actually copy that into remoting. Oops, I've actually run it there. Copy start.exe to remoting server. Okay, so here are our little programs that we created. So let's run the server component, and we'll unblock that port. So it started, And now what we'll do is we'll run the Windows program. CD remoting. And so normally this would run on the server and this would run on the client. So now what we can do is enter our country, and hopefully we get back the capital city. So what that's done is it's called up this remoting component and got some form of result from it. Sometimes what we have in our application is that we don't actually want to embed into the client or the server the TCP ports that are actually used. One of the advantages of .NET remoting is that we can take out the main parameters and place them in an XML file, which can be easily edited on either side to basically set up the TCP ports, the type of activation method, and so on. So for this, rather than creating our code to get the type of the remote object, we actually define a config file, which is an XML definition of all the main details that we have for the actual remotable object. So our code then is changed so that it reads in this file. So in this case, if we find that port 1234 is blocked, then we can easily change it to another port. So again, let's actually look at our configuration, our document, and there's a tutorial to do here. And so for this, we change our actual activation, our main activation method here, to be this now. And what we'll do is, just to save time, we'll actually put the config file on the C drive. So we'll call it test.conf. And then what we'll do is that we'll actually open up our XML file and just use Notepad to paste in, and then we can paste in the name that we've given it. We can take Notepad, file, save as, and we've called it test.config. And we can build. And now all that happens is that it will take its details from the config file. We just check that we have the right file, of which we have. We just run it again and check that we're not running. We already have it running in another window. So we'll try. So on the server we see an XML file such as this, and then on the client it's fairly similar, but we can define the IP address, the port, and the things like the assembly name and so on. With inside the client, we modify it to read in the config file, and then we can actually create an object, a remote object from this. Okay, so we have a client file and also one for the server. As long as we keep the port numbers the same, the IP address of the source of the destination correct, then we should be able to put all our parameters external to the actual program. Okay, so so that was a fairly messy process to actually add the reference of the DLL. Sometimes we don't actually want to give our DLL away if we have another developer working on it. Possibly we don't actually want them to get our DLL. So this is where interface definitions come in. Also, we'll learn how to use SOAP-SUDS to be able to remotely determine the interface of a remote object. So let's do some basic principles of interfaces and abstract classes, just to recap. So we quickly open up a previous presentation. So let's look at some basic concepts of inheritance. So inheritance inside an object-oriented language is that we can actually inherit characteristics and behaviors inside our classes. So with this, we might have a class. In this case, we've defined a class called people, and people have a name, and they might have a method to lowercase, to convert their name to lowercase. We can then inherit this into the definition of a new class. So in this case, we take the basic definition for people, and then we build a new class called profile. So it inherits the class people. So in this way, we can actually add in a new method. And then when we use the profile, we can see here that we can add name. Name is inherited from the people class, even though we've defined a new object called P1 based on profile. We can use the method inside the people class, and we've actually added a new method into it. So in this case, we can take a basic definition of an object, and then we can actually inherit all the characteristics and add our own. So we derive behaviors and characteristics. So we would show this as profile inherits from people. And we can see here, when we use P1, we can see here that we have a to lowercase method, which we actually have from here. We have various properties such as name, which we've inherited from people, and we've added in our own method called display. So we've seen in the previous example that we can actually use inheritance for the marshalling process. This shows another example. We've created two objects, P1 and P2, and we've given them different names, and we can actually display them. So an example in this case is that we can have what's called a sealed class. Sometimes we don't want a developer or someone to get access to the class that we've actually developed and then to be able to inherit from it. So in this case, we defined a seal class so that if someone tries to inherit from it, then we get errors, and what we've really done is stopped anyone from inheriting it. Sometimes we are given a class and we don't actually want to use the methods inside it. So what we will do is to override classes. So in this case that we have an example. So we've created a class and we can define one of our methods as virtual. If we define it as virtual, then it means that another class can actually override that class. So in this case, when the to lowercase method is called from profile, it will call this method and not this method. This one is here as a template or allows us to override that method. So this can happen many times, such as within graphics. If we have a class that accesses our graphics interface, we might want to customize some of the methods within inside it to optimize it for the hardware. So we can see here, in this case, when we've actually called up the toLowerCase method, the output that we get shows that this method has been overwritten, so it's obviously calling up this method here. We see this kind of thing where we actually create new objects, and we actually find that we have several methods which seem to be inherited from a global object. That's a basic definition of an object with inside .NET, and we'll often see finalize, equals, get type, and so on, which are the basic methods which are used with inside the object definition. And in .NET we can inherit from this object. So we see an example here with an override, and we have a virtual method, and in this case we're overriding the toString method. So the next basic concept that we have is what's called an abstract class. Within an abstract class, what we do is that we develop a class, and then we leave one or more of our methods ready to be written. So we call this an abstract class because we allow a developer to use the class, but what they must do is implement certain methods before they can actually use it. So this is defined as an abstract class, where we can actually define a class, and then we define the areas which need to be written before the class can actually be used. Okay, so here's an example, and we have a car and a way to fill its petrol. So let's look at this, and what we have is that we've actually defined our abstract class. So you can see there is no detail on the actual code. So when we inherit this class, then we must add in our own method before we can actually use it. So you can see here we haven't been, the program will exit because we haven't written the display lower method, even though we've derived from people. So now what we must do is that we must write that abstract class and then override it, and in this case the program will actually work. The next concept that we're going to look at inside the .NET remoting is the concept of interfaces. An interface is extremely useful in that we can actually send an interface definition to a remote developer and allow them to be able to understand the interface to our object. So with this we can actually send an interface definition of our object to the remote person, and then they can actually use it within inside their project. So let's take an example. Let's say we've got two formulas, this one and this one, related to electrical circuits. What we could do is that we could actually define an interface for the classes that we're going to create. So in this case we have a class called newCircuit, and within inside it has two properties, R1 and R2, we can set and get, and then it has two methods called calcParallel and calcSeries. In this way there is no parameters passed to here, but the result will be a double, and the parameters that we have here are also doubles. When we actually use, we import an interface definition into a project, so we can see there is no code associated with this. And then what we'll do is we'll inherit that for our new classes. So in this way, the interface will actually define all the details of the actual class. So we can see there that we've actually used it in some way to create a new class. So this shows an example of how we would actually use it. So let's now look back at our .NET remoting. Into interface definitions. So what we do for this is that we initially create an interface definition. We can then inherit from that interface definition to produce our new class, and we do the same again. We can add in our class definition on the server. So we just take our file again, which is here, and what we'll do is we'll redefine our server component. This is a new project, and we'll call that 3. We will create our class library, but in this time we'll create an interface definition. So we'll just call that new class. So we'll just add in our class definition, and it's just a standard class file that we have. In fact, we can go for an interface if we want. And we should be able to just paste that in. So then this is the interface file that we would give to, say, a remote developer. And then we can go back to our main class file. And then we can add in its details. So we can see here that we're taking in from the interface file with a namespace of ID capital. So then that will automatically be added in here, and then we're inheriting from that for our new class, and so on. So the same can happen at each of the stages. We can use this interface definition. The code should also work on the other side. So the key thing is that we can add in our interface definition to our activation component, and then again on the other side we can add in our interface, and we can get our code to use this rather than adding in the reference to the DLL. Okay, so this is a useful way for us to basically define what that interface actually looks like. And when we're building, the system can actually check all our usages of the remote component. Same thing happens on the client side. We can have this interface definition that we can use. It doesn't actually expose any of the code at all, but will actually give the definition for how to use the remote object. The last basic concept that we'll look at is how to use soapsuds. So with this, what we can actually do is that we can actually run our remote object, and then we can use soapsuds to actually access it remotely using the URI that we used before. And then what that will do is to return back a DLL definition of our remotable class. We can then add this DLL in as a reference inside our project. So let's look at some very basic principles that we've covered in this session. So one of the main concepts that we have is that a client object requests an instance of a server. Then the remoting system creates a proxy to be able to communicate with the server object. The client then calls the methods on the server object, but it is the proxy that does the call through. The remoting system on the other side then receives the call, invokes the object, and then actually makes the call to a method and returns back any results back to the client. We looked at the marshalling process, and it's the way for us to be able to expose an object to client applications. We can do marshal by value, where the actual objects are actually copied from the server to the client. So this can be quite a lengthy time to serialize an object. So if it was a database or a large object, then it might take some time. We can also have marshal by reference, and with this the object is actually still kept on the server, and then we can then reference it. So an example of marshal by value is we put a serializable modifier before the class, and then by reference then we actually add in the marshal by reference object class and derive from this for our object. So for small objects, the marshal by value is fine, because we can pass small values such as integers, floating points and so on fairly quickly inside encapsulation. But for large objects, the fastest is likely to be marshal by reference. For objects that are only available on a server, such as a database object, then again we use marshal by reference. When we're selecting our channel and our formatter, the most efficient one in terms of formatting and channels is TCP with binary. That's the fastest we can get. The least efficient is with SOAP and with HTTP. The best method for channels and for getting over firewalls is HTTP, and the best for interoperability is some SOAP formatter. The worst method for channels and on interoperability is TCP with binary. The default is TCP for binary and HTTP for SOAP. The other concept we came across is that the lifetime for a server activated object is controlled by a server, and for a client activation it's controlled by the client. Okay, so that's the end of this presentation.